this is the start of section 4.5, and 4.5 is all about dilations. And dilations are different than all the transformations we've done up to this point, because all the transformations up to this point have been rigid motions. And if you remember, a rigid motion is just an operation in which produces a congruent figure. Dilations don't produce congruent figures. So dilations make something get bigger or smaller by a specific scale factor. And we'll talk in a minute, how to read scale factors and how to calculate them and all that. But they do get bigger or smaller. Now, they are proportional, so the ratios stay the same between the figures and from the points of the center of dilation. And then I also want to point out that, like here, we start with the blue figure and we get to the red figure. Notice that C is the center of dilation. Okay, so if I connect from C to Q prime, notice it'll pass right through Q. Okay, if I draw from C to P prime, it will pass right through point P. And when I draw from C to R prime, it'll pass through R. So that's something else to note. All right, so let's go over dilation. All right, a dilation is a transformation in which a figure is one of two things. It's either enlarged or it's reduced, okay, with respect to a fixed point C. Now that fixed point, what I mean by fixed is it means it doesn't move, it stays the same. Now the center of dilation is what that fixed point is called. Okay, and it's the point in which a figure is enlarged or reduced in respect to. Okay, the scale factor is the ratio, and most of the time when we think of a ratio, we think of like a fraction. Usually these are written as fractions. The ratio of the side lengths of the corresponding sides of the pre-image and the image. Okay, so it's a comparison of how much bigger or how much smaller we get. All right, so an enlargement, as you could probably guess, is when a geometric figure gets bigger or larger, whatever way you want to write it. And we know that in an enlargement, K, guys, for some reason, K is the scale factor. I don't know, I didn't call it that, but just overall, if you ever see a K and you don't know what it stands for, usually it's a scale factor. So an enlargement is when our K value or a scale factor is greater than 1. Okay, and I probably should have put the absolute value of K is greater than 1. And then a reduction is when a figure gets smaller, and we know that the scale factor of this, the absolute value, is less than 1. All right, so here is an example. So C is our center of dilation, and so this figure is mapped onto this figure. And we know that this figure comes first. This is our pre-image. I'm going to put PI. And our P prime is our image. And we know that because our P comes before our P prime. Our pre-image comes before our image. So anytime to find the scale factor, you do image over pre-image. Okay? So if I try to find the scale factor here, if this is our image, we can find the ratio of how far it is from our center of dilation. So it's image, which is 12, over pre-image, which is 8. So to reduce that, that's 3/2. Okay, and we are getting bigger, so it is an enlargement. Okay, now if we would have got like 2/3, but we seen it got bigger, that should be a red flag that we flipped these two. Okay, so I want you to do B on your own, and then we'll go over it. First, identify what's the pre-image and what's the image, and then find your scale factor. All right, so if I look at this, my P comes before my P prime. So my P is my pre-image, and my P prime is my image. Okay, and scale factor is image over pre-image. So my image, so from here to here is 18. And my pre-image from here to here is 30. So 18 over 30, if I reduce that, what is that, 3/5? Okay, so my scale factor is 3/5. And I can look at this and see it's getting smaller, or I can just look at the scale factor and say, yep, that's less than 1. And so we know this is a reduction. All right, go ahead and do this one on your own as well. This is very similar to the ones we just did. It's just written in words. And I know we all hate word problems, but they're not that bad. So try to do it on your own. The only way we're going to get better is to do them. All right, so it tells us that CP prime is 3 and that CP is 12. Okay, and we want to find the scale factor. Now remember, the scale factor is image over pre-image. Okay, now I need to look at these and decide which one's the image and which one's the pre-image. So P always comes before P prime, so that means this has to be the pre-image and this has to be the image. So my scale factor, if I substitute, my scale factor is 3 over 12, which is 1/4. Okay, now 1/4 is smaller, or sorry, 1/4 is smaller than 1, and therefore my scale factor is less than 1, so we know this has to be a reduction. Or you could simply look it up here, and if this is the pre-image, if it goes from 12 to 3, yes, that's a reduction. You could look at it that way. All right, let's look at example 3 now, guys. We have triangle ABC down here, and I want to dilate it by a scale factor of 2. Okay, so all I need to do here is, I'm going to write this down, my A, B, and my C. So my A is 2, 1, my B is 4, 1, and my C is 4, -1. So if I'm going to dilate it by a scale factor of 2, all that means is I'm going to multiply each one of these coordinates by 2. Okay, so first of all, this is a -1, not a -2. Sorry. All right, and so my 2 times 2, my A prime is now 2 times 2 is 4, 1 times 2 is 2. My B prime is now 4 times 2 is 8, 1 times 2 is 2. And then my C prime, my 4 times 2 is 8, 2 times -1 is -2, and then I'm going to plot these points. All right, so when we plot it, it looks something like this. Hopefully yours looks a little better than mine. And notice if we go from the center of dilation, which is the origin, if we go through our reflected point, we pass through A. If I go through my B prime, I pass through B, and if we go through my C prime, I pass through C to get there. All right, so these are kind of the same. So I want you to go through, do this one on your own, 4B on your own, 5A on your own, and 5B on your own, and then we will go over them. All right, this is what you should have gotten for example 4A. Here's 4B. All right, now 5A and 5B, we have a negative scale factor. So we treat it just the same, so we just multiply everything by a -1/2 instead of a 1/2. But notice when we plot it, it's also a rotation of 180. Okay, so it goes over. And the same thing on 5B. We had a -2 scale factor, so it got larger by a scale factor of 2, but it also rotated around the origin of 180 degrees. All right, let's look at example 6. So we're making our own photo stickers. So we're going to take a photo of ourselves, and then we're going to dilate them and make stickers out of them. So our photo is 4 inches by 4 inches. Okay, and the stickers are 1.1 inches by 1.1 inches. Okay, and so now we want to find these scale factors. So remember the scale factor is image over pre-image. All right, now we need to decide which is the image over which is the pre-image. Okay, so we're starting with our photo, and then we're ending with the stickers, right? So what we start with is our pre-image. What we end with is our image. Okay, so if I just plug it in, so image is 1.1 over my pre-image is 4. If I put that into my calculator, 1.1 divided by 4, it gives me 0.275. So that would be my scale factor. All right, let's look at example 7. It says you're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. So this is very important. Okay, when I say something is 6 times the object's actual size, what vocab word am I referring to? I'm referring to the scale factor. So we know the scale factor is 6. Or if you like to write it as a fraction, you could put 6 to 1. That's okay. Determine the length image of the spider seen through the magnifying glass. Okay, so this is what it is without the magnifying glass. Okay, so what is it with the magnifying glass if our scale factor is 6? Okay, so we just take 1.5, we're making it 6 times bigger. So we're just going to do times 6. So 1.5 times 6, put on my calculator, gives me 9. So when I look through the magnifying glass, it looks like it's 9 centimeters. All right, go ahead, do example 8, and then we'll go over it. All right, so we're going to the optometrist. We dilate the eyes. We go from 4.5 millimeters to 8 millimeters, okay? So we need to figure out which is my pre-image and which is my image. We start with the 4.5, we end with the 8. So if we start, that comes before we end. So our pre-image is our starting. So our pre-image is 4.5, our image is 8.8. And then to find the scale factor, remember it's just image divided by pre-image, which is 8 over 4.5. And if you put that into your calculator, that's roughly 1.8-ish. All right, let's do the last example. I want you to try to do this one on your own, then we'll go over it, and then we will be done for this section. All right, guys, if you remember from the last spider example, the magnifying glass, it was actually example 7, not 6, but the magnifying glass magnified it by a scale factor of 6. It made it 6 times bigger. So if when we look through the magnifying glass, it's 12.6 centimeters, we want to know what it is if we're not looking through the magnifying glass. We want to know the regular length of the spider. So to do that, rather than multiply it by 6, we would divide it by 6. And when we do that, we get 2.1 centimeters. So the spider's actual length would be 2.1 centimeters.